Okay, trigonometric functions, a unit circle approach. We'll look at trigonometric functions, the values of those trigonometric functions, and their identities. A function is a rule that assigns to each real number another real number. We've learned that before. And in this section, we'll use properties of the unit circle to define the trigonometric functions. Now we know to find a terminal point x comma y for a given real number, we'll move the distance along the unit circle, and we start at 1, 0, right here as we looked at in the last section. And we can move counterclockwise if it's positive and clockwise if it's negative. We now will use the x and y coordinates of the point to define several functions. For instance, if we define the function called sine by assigning to each real number t the y coordinate, and again, I'm going to repeat that, sine is the y coordinate of the terminal point determined by t. So the functions cosine, tangent, cosecant, and secant, and finally cotangent, are all defined by using the coordinates of x comma y. So here we go. We have the sine value is the y value. The cosine value is the x value. So therefore, the tangent would be y over x because that's sine over cosine. Cosecant would be 1 over y. Secant would be 1 over x. And cotangent would be the reciprocal of y over x, and it's x over y. Going to find the 6 trigonometric functions of each given real number. We have pi over 3 and pi over 2. So from the table, we see that the terminal point determined by t equals pi over 3, come down here, would be 1/2 square root of 3 over 2. The next one, we're going to look at pi over 2, so that will be 1, 0. Since the coordinates x equal 1/2 and y equals square root of 3 over 2, the sine value is the y value, so that will be the square root of 3 over 2. The cosine value, which is the x value, is going to be 1/2. So again, cosine x, sine y. And sometimes I tell people to try to remember it by alphabetical order. In alphabetical order, cosine comes before sine, so the cosine is x, the sine is y. The tangent, of course, is sine over cosine, so that will reduce to the square root of 3. Cosecant is your 1 over sine, so you're going to do your reciprocal and rationalize. And secant is your 1 over cosine, so then you will flip over your 1/2 and get 2. Cotangent would be your reciprocal of tangent, square root of 3 over 3. The terminal point determined by pi over 2 is 0, 1. So the sine of pi over 2 would be 1. The cosine is going to be 0. Now again, let's review that. That's because this is my y value and this is my x value. This is my y value and this is my x value. Cosecant would be 1 over 1, which is 1. Cotangent is your sine over cosine. So, or I mean your cosine over sine. So that would be 0 over 1. But my tangent, which is sine over cosine, that would be 1 over, Now, let me make that a little bit clearer. Erase that. Okay, so that would be 1 over 0. Can't happen, right? And my secant, which would be 1 over 0, can't happen, are undefined. So that means we would have asymptotes there. So here is your table that you should definitely know. I think you will see this on a quiz coming very, very soon. So make sure you know these values. If you know your sine and your cosine, then you can figure out your tangent, cosecant, secant, and cotangent. The functions tangent and secant have x in the denominator, so they're not defined whenever x equals 0. When looking at the domains of trig functions, you see that for sine and cosine, you have all real numbers. Tangent and secant, you have all real numbers other than pi over 2 plus n times pi, because it is a periodic function, so it's going to continue to repeat where 0 is in the denominator. And cotangent and cosecant will again repeat at n pi for any integer of n. So let's take a look at values of trig functions. Compute the other values of trig functions. We're going to determine their signs. Again, we need to know what quadrant they are in. So if you have a terminal t that lies in quadrant 3, then the signs are both negative. So my sine, my cosecant, and my secant would all be negative, whereas tangent and cotangent would be positive because it would be a negative over a negative. So quadrant 1, everything's positive, nothing's negative. Quadrant 2, because in quadrant 2, my y values are positive, my sine and cosecant will be positive, and then my x values are negative. So anything that has an x value in it one time would be negative. So that's cosine, secant, tangent, and cotangent. In quadrant 3, I have a negative over a negative when I have tangent and cotangent, and I have one negative for cosecant, sine, cosine, and secant. In quadrant 4, I have a positive over a negative in sine, cosecant, tangent, and cotangent. But since my quadrant 4 has my x value being positive, my cosine and my secant are going to be positive functions. So let's take a look at finding these values. Here I have my 2 pi over 3, which is in second quadrant. My reference number is pi over 3. Second quadrant, so I know it's going to have to make sure that my x value is negative. And I will have negative 1/2. For negative pi over 3, I'm going to go clockwise from 1, 0. And I'll be in quadrant 4, so it will be negative. So my negative tangent pi over 3 is going to be negative square root of 3. Okay, since I have 19 pi over 4 here, I want to take a look at how many times it will go around my axes. So remember, 2 pi is all the way around. So if I go once, that would be 2 pi. I go again, that would be 4 pi. Here, if I subtract 2 pi away from 19 pi over 4, which would be 8 pi over 4, I have 11 pi over 4. And then I subtract again another 2 pi, and I have 3 pi over 4 left. So if I start back from the beginning and I go 3 pi over 4 more, then I'm in the second quadrant. And the second quadrant is where my x value is negative and my y value is positive. And I kind of drew over that, but it says the same thing. So my terminal point of 3 pi over 4 again is in quadrant 2, and the sign value is then positive. So my value of pi over 4 would be the square root of 2 over 2, as indicated by my reference number when I'm going 3 pi over 4. And again, the reference number is my distance from my x-axis. If I come around here to 3 pi over 4, I'm going to then go from my x-axis to here. So that's how I'm getting pi over 4. And my sign value is my y, so it is positive. Fortunately, program directly into your scientific calculators or mathematical procedures that will find these values of sine, cosine, and tangent correct to the number of digits on display. So you have to make sure that you put your calculator in radian mode to evaluate these functions. So in order to find cosecant, secant, cotangent, using a calculator, we need to know these reciprocal relations, which you should have learned a while back, that cosecant is 1 over sine, secant is 1 over cosine, and of course, cotangent is 1 over tangent. These are considered identities because they can be substituted for each other. Now, make sure your calculator again is set to radian mode. Okay, so we want to make sure we're on radian mode. And we're going to find these values to 6 decimal places. So try that in your calculator. Put this on pause and try that. And make sure you're getting the correct answers. So if we're going to consider the relationship between trigonometric functions and those of negative t means we're going into the clockwise direction. T means we're going into the counterclockwise direction. We will see that the sine of negative t is a negative y, which is negative sine t. We'll see that the cosine of negative t is x, and that is the positive cosine of t. Why? Because my x value is still still positive right here. So even though I'm going down, if I'm in the fourth quadrant, my x value is still positive. Now my tangent is sine over cosine, so if I have a negative sine over a positive cosine, it's going to be negative. Whenever you have the value come out negative, that means that they are then odd functions. So my sine and my tangent are odd functions, whereas my cosine is an even function. So the reciprocal of an even function is going to be an even function, and the reciprocal of an odd function is going to be an odd function. So that will give you all 6 of your functions. Sine, odd, cosecant, odd, tangent, odd, cotangent, odd. However, cosine and secant are both even. So we're going to use the even-odd properties of the function to determine the values. Here we have a sine of negative pi over 6. Let's think about that. We're going to go in the negative, which is the clockwise direction of pi over 6. And we're looking at the sine value, which is your y value. And in the second one, we're looking at the cosine of negative pi over 4, which is going again in clockwise direction, but we are looking at the cosine, which is your x value. So here's your special values. We have our sine of pi over 6. And since our y value is negative, it will be negative. And we have our cosine of pi over 4. And since our cosine value is positive, our x value in the fourth quadrant, when I go backwards pi over 4, it is also positive because it is even and sine is odd. Now, a couple more things we need to take a look at are the fundamental identities that you should know. And yes, when I say know, means you're going to have to start with memorization and then continue to quiz yourself until you know them. So hopefully you learned a lot of these in high school when you studied trig. And then we have the Pythagorean identities of sine squared plus cosine squared equals 1, tangent squared plus 1 equals secant squared, and 1 plus cotangent squared t is cosecant squared t. So these are your most important identities that you should know. And as their name indicates, identities play a central role in trigonometry because we can use them to relate to other trig functions. In other words, you can substitute one in for the other. If cotangent of 3 over 5 and t is in quadrant 4, now again, let's think about quadrant 4, what that looks like. Quadrant 4 is here, where cosine is the x value. So we're going to take a look at the Pythagorean identity, and we're going to plug our cosine value in. So I will square it, subtract it from both sides, and then take the square root, and I will get plus or minus 4/5. Now I have to ask myself, sine in the fourth quadrant would give me what? Is sine positive or negative? It's negative since it's in the fourth quadrant. My y value is in fact negative. Now we know both sine and cosine, we can find the values of other trig functions, so we can just go ahead and find our secant, cosecant, tangent, and cotangent. And if you have any questions concerning any of these, again, please text me, email me. We can set up a time to go over them, or of course, ask some questions in class. So this is it for 5-2, and that will be, I believe, week 10. You guys take care, and I will talk with you soon.